All right, so the first one that I want to go over together is number 3. So it says dy dx equals x to the 4th times y, and there is no initial condition. So we're just going to leave c in there. It's going to be the general solution, which remember that's an infinite number of answers. So separating the variables, we're going to divide over the y and then multiply over the dx. And then antiderivative. So on the left side, that's going to give us ln of y. And then over here, that'll be 1/5 x to the 5th plus c. And we're not going to find what c is. Again, this is going to be the general solution. So we're going to skip that step. We just have to get y by itself. So to cancel out ln, we're going to exponentiate. So it's e to the power of all this stuff. So remember, e is a number, 2.718. C is a number, so we just put that out front as one big constant. So c e to the 1/5 x to the 5th. And just remember, you need the plus and minus. Whenever you drop the absolute value, that's where you put the plus and minus. Absolute value means distance from 0. And so you can go in the positive direction or the negative direction. That's why we have plus minus for absolute value. And if you want to think of it in terms of these solutions, again, remember it's an infinite number of answers. And if you're graphing an exponential, it's going to have a horizontal asymptote, and you could have a swoop that's up here if it's positive, or you could have a swoop that's down here if it's negative. So that's why the plus minus is really important, because the answers could be up here or they could be down here. This represents an infinite number of answers. And then the other one that I wanted us to look at is number 4. So this is dy dx equals y cubed. And this one has an initial condition, y of 0 equals 1. So when you divide over the y cubed, it would look like this, 1 over y cubed. That is not going to go to ln, and it wouldn't be ln of y cubed. You can't do that. The only one that pattern works for is 1 over y. We'll give you ln of y. If it's y to the 3rd or the 4th or to anything else, it's not going to do that. So instead, you have to deal with the negative exponent, which is what made this problem a little trickier. And then multiply over the dx. Because anytime there's a negative sign, that just kind of throws everybody off. It's just negatives are more difficult to deal with. So we're going to add 1 to the power. That makes it less negative. So it'll be -2. And then you have to divide by that, so the reciprocal goes out front. I had a lot of people put a negative sign, but not the 1/2. Just remember, you're reciprocating this exponent. So if there's a -2 there, you got to put a -1/2 out front. If you wanted to put a 1 in here, you could do that. The antiderivative of just dx, or 1 dx, would just be x, and then plus a constant. So the next thing you want to do is plug these values in to find c. I always like to fix the negative exponent first. I think it's easier to plug in when you don't have a negative. The negative exponent puts that back down in the denominator. So that y squared goes down to the denominator. We're going to plug in 0 for x and 1 for y, and that will give us -1/2 for our constant value. So I'm going to recopy this step just exactly like it looks, except instead of c, I'm going to put -1/2. And then the last thing you have to do is get y by itself. So what is going to happen algebraically? So you're going to multiply over the y squared and divide over the x -1/2. These two things I put in parentheses are just going to switch places, essentially. You're multiplying over the y squared, dividing over all of this. So again, algebra is just like moving stuff around. So those two things switch places. Last step is to square root. We want the positive square root because our initial condition is positive. And so you just need to square root this whole thing. Now I'm going to distribute the 2 just because a lot of people did. You don't have to, you can just leave it right like that. But a lot of people did. So it was 2x minus 1. So those are the 2 that I wanted to go over. I'm going to open it up to your questions. So are there any others from the test that you guys want to look at? All right, I'm seeing 6 and 7. So let's do those 2. All right, so number 6. It says the slope of a curve is given by, all right, slope means derivative, so that's dy dx is given by 3x squared over y squared. So when we separate the variables, it's really, you can think of it as cross multiplication for this one. We're going to multiply over the y squared and then multiply over the dx. All right, and then antiderivative. So the left side, that's going to be 1/3 y cubed. And then the right side, that would be x cubed and then plus a constant. Oh, and this one had an initial condition. I'm sorry, I should have written that when I wrote down the problem. It says the curve passes through the point 2, 3. So we're going to plug in 2 for x and 3 for y. So if x is 2, 2 cubed is 8. And then y is 3. So 3 cubed is 27. 1/3 of 27 is 9. Subtract this over, and so c is 1. So I'm going to recopy this step and put in 1 for c. And then last thing, you want to get y by itself. So we're going to multiply both sides by 3 to cancel out the 1/3. So it would be 3 times all of this. You can either just put a 3 out front, put parentheses around this, or you can distribute the 3 to everything. I'm going to distribute it because that's what most of you guys did, but either way is fine. And then last thing is cube root. So there's a lot of 3's in this problem. So cube root of all of that. All right, and then number 7, a particle begins at 0, 1. So that's the initial condition, moves along the y-axis so that its velocity dy dt is double the position y. So dy dt is 2y, it's double the position y. And it said the initial condition was 0, 1. So we're going to divide over the y and then multiply over the dt. All right, so this will give us ln of y equals 2t plus a constant. And we're going to plug in 0 for t and 1 for y. So if t is 0, that's just going to be 0. And actually, if we plug in 1 for y, ln of 1 is 0. So we get that c is 0. So there is a constant, it's just 0. So when we recopy this line, I'm just not going to put the plus c in there. And I had some people put plus 0. That's totally fine. You can leave that in there. If you just want to like make sure like, hey, I didn't forget it. It's just that it's 0, then that's fine. And then to get rid of ln, we're going to exponentiate both sides. So e to the power 2t. To compare and contrast, this one gets a plus minus because it's the general solution. We want an infinite number of answers. They can be positive or they can be negative. This one does not get a plus minus. We would choose, do we want positive or do we want negative? You're like making a choice, and we want positive because our initial condition is positive. If this was a negative one, we would put a negative in front of that.